All right, welcome to the video on how to do these Bohr diagrams. This video will be so much shorter than electron configuration if you watched that one first, because it's so much easier than electron configuration. It is not difficult at all. So what we're doing is learning how to fill out this Bohr diagram. We're going to do that example in a second, but I'm going to show you this. We are putting electrons into their proper shells or energy levels. Our first shell can hold 2 electrons, our second shell can hold 8 electrons, and our third shell can hold 8 electrons in this instance. After 8 electrons, Bohr diagram becomes 2. Oh, I forgot my O. There it is. Bohr diagrams becomes too simple for us to use, and then that is why we need to learn electron configuration in the first place, because Bohr diagrams is not complex enough for the complex elements. But let's go ahead and do an example of this, which is aluminum is going to be our example. It's one we did in the notes, but if you weren't here, hopefully this will be helpful. So in my nucleus, I have my protons and my neutrons, because that's where protons and neutrons are. So this is my nucleus. And I can see on aluminum, I have, I don't know if you can see because of the glare, an atomic number of 13 and a mass of 26.9, which I can round up to 27. So my atomic number is 13, which means that I need 13 protons. And I also have 13 electrons. So TE is total electrons. And then neutrons is where you have to do something new. Oh, you're calculating neutrons. You have to do something new. Okay, so you do mass minus atomic number. So 27 minus 13 is 14 neutrons. Okay, we're going to fill our electrons into the proper shells. Please remember, first shell can hold 2, second shell can hold 8, third shell can hold 8. So I'm going to do 2 electrons in my first shell, so my lowest energy level is the one closest to the nucleus. Here's 1 electron, here's 2 electrons. My second shell can hold 8, so it doesn't really matter where you put them. You can spread them out, you can pair them up. We will be pairing them up when we do orbital diagrams and things like that. But for the Bohr diagram, we don't really need to do that. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that gives me 10 total electrons on my diagram so far, because I have 2 here and 8 here. So that's 10 total, but I need 13. So I need 3 more. So I'm going to put 3 more on my third shell. And remember, on the Bohr diagram, we won't go past that third shell, because the rules kind of fall apart after that. We need some more information after that. So my valence electrons are then the electrons on the outer shell of my atom. So I would have, in this instance, 1, 2, 3 valence electrons. Let me show you this example right here. This is boron, and boron also has 1, 2, 3 valence electrons. You can't have 0 valence electrons. So even though I didn't go into my third shell, that third shell does not exist unless there's an electron there. So it may be on there, that third shell may be on your picture, because I'm going to be copying and pasting these pictures, but you don't have a third shell unless there's an electron there. So in this instance, even though I have 5 total electrons versus having 13, I still have 3 valence electrons. So I hope that that was a little bit helpful for you in doing Bohr diagrams and figuring out your valence electrons from these diagrams. Thank you guys. Bye.